Hello all, welcome to today's session. Today I'll not be going specific into any of the core services. Like I'll not be, like starting with one of these: compute, storage, networking, database, or security. But what I'll be doing is that I'll be probably trying to explain the overall concepts, of high availability, resilience, and we'll see how we can like achieve scaling on AWS, and that's where you will see that this particular tab. So this is a bit old a blog series of blogs. It's a 4-part blog, scaling on AWS, and bit old, but the concepts are quite important, and they're very much relevant. So any stats in this blog, recheck it with the latest ones. But overall, from the concepts perspective of how to scale or how to design your architecture on AWS, this is a very good starting point. So today in this session, we'll be going through this particular blog series, and I'll try and explain at a very high level that how you can design your you can start creating a, let's say, a multi-tier web application on AWS and serve your customer one, versus down the line when you have million customers. So how you can start building slowly and slowly, and scale out. That's what we're going to look in today. So that should cover from the concepts perspective a lot of things, that how to design a multi-tier architecture, how to design a highly available and fault tolerant architectures, decoupling mechanisms, a bit of resilient storage. It's going to, like, at a conceptual level, it is going to explain a lot of things, but not a specific individual core service level. But hopefully that will be a good starting point. So here, let's start going through this part one of the blog. And scaling your on-premise infrastructure is hard. Yes, we do understand that. If you have a let's say a data center in which you have a particular server, and you have installed all your applications onto that server, and in case the load increases, then to scale it, what you'll have to do is purchase additional hardware, and then you'll have to get additional software licenses if there is there, and then you'll have to set up your own load balancer and everything. So it becomes very hard if it is on an on-prem infrastructure. But if it is on cloud, and especially AWS, then there are a lot of services that you can leverage to scale based on what design or what architecture you are using. And that's what we are going to look into. But before that, let's have a quick background knowledge on AWS. We do have a lot of regions. Again, as I said, this is an old article. So at that time, we had 11 regions. Now we have more regions. So always you can go to the latest one to see the latest figures. So we have 24 launch regions and 3 announced regions for that. And with regions, which specific region. So whenever you're going to start, let's say, an application for a specific use case, you would be starting with choosing which region you should be provisioning your resources, and that decision will be based on proximity to the end user, that where exactly your end users are. So let's say, though you are creating the application in or developing the application from APAC region, but most of your customers are in US regions, then you would like to deploy your application in a US region, specific US region. And definitely they depend upon data regulatory requirements. For example, in Europe, we have GDPR. So with that, you'll have to ensure that where your exact data is residing. And then the expansion strategy, cost. So cost of each region is not same, and all the pricing and the cost is public. So you would like to compare that to see which region you would like to choose for your specific cost. And then the service availability, like not every service is available in every region, though that is the intent. But when the new service is launched, they are launched slowly, and it based upon the demand of that particular service in that particular region. So you would like to have that also into account while choosing a region when you're creating a new application. Okay, so with that, then the another basic concept that we should be understanding by now is availability zones. So each region is comprised of multiple availability zones, right? And these availability zones like as you see here, use independent power grid, sit on different fault lines and flood plains, and provide single digit millisecond late connectivity to other AZ. So they are separated, if not geographically, but they are separated quite far apart so that they have their own independent power grids, they have their own fault lines, they are on different floodplains and stuff. So uh, they provide you a level of resiliency that is required. And while providing that level of resiliency, they have ensured that the latency of whether a data transfer or access between these availability zones is really, really low. A single digit millisecond connectivity is available between these availability zones. So while designing your application, you need to always think about high availability. So you need to have your services running on multiple availability zones, so that in case if there is a downtime in specific availability zone, then you should still your application should be accessible. But when it comes to disaster recovery, you might want to have the backup of your entire data based on your RTO and RPO requirements in another region. That in case if a particular region goes down, then you should be able to quickly reprovision those resources using the backed up data. And there are multiple types of like disaster recovery, like hot, warm, cold, and we'll discuss those in detail based on those and your RTRP requirements. You would like to set up your disaster recovery plan accordingly. And then the overview of AWS platform. Yeah, while you'll read it, go ahead and read all the in a more granular way, but I'm going to skim through the document and not going into each and every aspect of it. But yeah, from the overview perspective, as we know, we have network services, compute services, storage, then we have database, we have networking, all of that. And then there's a low level infrastructure that AWS manages, but there are a lot of application level services, like for example S2S, they are there, which you can be using. There are a lot of data services that will be there. And then we have like ways to automate or monitor or administer and security your the entire infrastructure. A lot of tools are provided. You need to configure those tools in a way that you would like to use for your specific use case, and that's where majority of our focus would be. Okay, so this is interesting. So day one, user one. So the for the very first time, so like if you're from an on-prem world, then even on the day one, you'll have to think about who or what is the target audience and how many would be using that, and accordingly you need to provision resources. So you might have to think on day one about 2 years down the line how many users you would be expecting, and you would like to provision it in that way. But using AWS, it's more like you can always start designing for user one and then slowly fan out based on how it increases. So on the day one, let's say you're starting with the very first application you need to just spin up. So you're going to use Amazon EC2 particular AMI machine, whichever you would like, and deploy your application onto it, and you're up and running. And we do have AWS Marketplace, which we discussed in Cloud Practitioner, in which a lot of third-party vendors have provided their softwares, which you can directly install and click and install. So, for example, Labstack or by Bitmoney, it is going to give you, let's say, a normal website. You can simply continue and you can deploy it. And from a very basic, very basic infrastructure, this is how it will be looking like. That you have a specific region that you chose, you created a VPC. In that VPC, you have used one availability zone to deploy your one EC2 instance, which has your application running. And your application here might be a three-tier application. You have a web front end, you have an application layer, you have database, but all of that you might choose to deploy into one EC2 instance. And then you have internet gateway to which that will application would be accessed. Then we have a Route 53, which is a service that is going to, let's say you have a website, www.abcd.com. It is going to route you to the exact IP address where your service is running, public IP address where your service is running. So this is a like I say, a very basic level of infrastructure that is there. And as you see, what all services it is using is Amazon EC2, VPC mainly, that is required for running any EC2 instance. Then we have a VPC subnet, which is for this particular instance. We have Route 53, which is a highly available domain name service system web service. It So, if, for example, you have translating example.com to public IP address, that's what your Route 53 does. So with this, you are start serving your like requests to your users. But let's say if your number of users increases, then how you should be planning to span this out. The first thing that you might want to do is, instead of having everything on one server, you would like to have different tiers on different servers. You would like to have your application server and database server separate, so that based on the load you can independently scale them. So that can be the one thing that you would be doing here, independently scaling them. Okay, and so if you don't do this decoupling, then what will be the drawback of that? So everything, let's see, is on your EC2 instance, and if the traffic increases, then you might want to scale it, and you might want to, then you'll have to scale it vertically. By vertical scaling, what you mean that you give a CPU, a more RAM, a more storage to this EC2 instance, so that is able to do everything, whether it is for the application layer, whether it's for database layer. But eventually that is going to hit a limit. It cannot do after a particular limit your vertical scaling. So the way to do is go for a horizontal scaling. Horizontal scaling is that you can have multiple EC2 instances. I have to ask you to get on mute. Sorry, yeah. You have to do a horizontal scaling. Then you can have multiple EC2 instances, and then each EC2 instance will be having the application layer and database layer. So instead of doing the horizontal scaling with all the servers on one, it is better to go for a decoupling first. You decouple it into your application layer separately and your database layer separately, and then you can horizontally scale each of them independently. For EC2 instance, we can understand that horizontal scaling is like running the same application service on multiple instances, and then we can have a load balancer which load balances on them. For database instance, we'll talk here about the concepts of multiple AZ and read replicas, and how we can horizontally scale your database, which is a bit more tricky thing. So yeah, here it is now. Now, because we need to horizontally scale, then we'll have to have an elastic load balancer, so that whenever there's a request that is coming, it load balances between the multiple EC2 instances for the application layer, and all of them goes to one database. And now, if you see, to achieve the high availability, everything till now was on a single availability zone, but now to make it highly available, because we are anyways horizontally scaling, then and the price does not vary between availability zones. It does vary only in the regions. So you can have this EC2 instance in another availability zone. So the advantage here would be that in case if this availability zone is down, then at least your application layer will be working. We'll talk about database in a moment, but that's how you can achieve high availability for your application layer, and then you can scale it based on your elastic load balancer. And so that was the part. Now this, you have now architecture through which you can like serve your not a very high volume, but at least a low to medium volume. You can start serving your customers. So that's the summary of this particular first part of the blog. Now we'll move on to the second part, which is scaling on AWS for more than 10K users. So now your website is started getting popular, let's say 6 months down the line, and there are more and more users coming. Then how would you like to architect your whole application or your multi-tier application? So now here we'll talk about, in case if we have more than 10 users, then how we will be able to start serving people. We do know that we have created an independent data tier, right? But then we'll talk about how to make this database more performant and highly available and resilient. So first we will look into the different types of databases that we have. And as we discussed before, the SQL database offering is Amazon RDS, and NoSQL database offering is Amazon DynamoDB. So SQL database is mainly for data which has relationships. It's based on the ACID principle, as we talked about, and this is what is most of the applications do use from a use case to use case basis, obviously. So RDS gives you an option to choose from variety of engines, including there are 6 to be exact: Microsoft SQL Server, Oracle, MySQL, PostgreSQL, and Aurora. And as I said, Aurora is a cognitive database from AWS, and they support 2 engines, MySQL and PostgreSQL. For SQL Server and Oracle, as you know, they are mainly have licenses. They are from third-party vendors, Microsoft and Oracle. So they have a flexible licensing model. You can bring your own license, or you can use the license as a reserved from RDS directly. MySQL and PostgreSQL are open source, and AWS RDS uses those open source, and it relieves you from a lot of administrative tasks from that. DynamoDB, on the other hand, is a NoSQL offering. It supports both document-based as well as key value-based database. So it supports both document and key value store models. So I'll not go into deep of what exactly SQL or NoSQL is, but this is something I believe most of you tech people in the group would be understanding it. Yeah, just understand that as SQL is based on ACID and NoSQL is based on base, and yeah, there are a few differences that are listed here, which you can go through. But yes, coming back to our database scaling, how we can do. So here, if you see that it's a very typical 3-tier web application. So this you would see is that the layer here, it is application. Let's say this is a web front end tier. So this web front-end tier would be scaled into multiple availability zones and has elastic load balance to balance the load. Then we have application layer, which will be in a private subnet. So if you see the web front-end, which is in a public subnet, and your application layer is in the private subnet. So your application layer is not directly accessible from the internet. It's only the web front-end which is accessible from the internet. When we'll talk about security, we'll also talk about bastion host, which comes in front of it, so that the bastion host is available from the public internet, and your web layer is in a private subnet. But for simplicity, we are right now having the web layer in public subnet. And with the application layer talks to database, and the database is also in a private subnet. And as we see here, in the previous example, we had just one instance of database, but here now we have a database with a master and a slave. So this is a kind of more of a multi-AZ feature, which is a multiple availability zone feature, and this is mainly for disaster recovery, or not for disaster recovery, I would say high availability. So if you want to have your database highly available, then you need to enable multi-AZ feature. What exactly it means is that it is going to enable a synchronous replication. And this is important to understand. It is going to enable a synchronous replication between your master and slave. So any write that is happening onto your database, it is going to synchronously replicate it to your slave before saying that the particular data is written. Having said that, your application will connect only to your master. It is not going to connect to your slave unless there is a failover that is required. So let's say in case if the master goes down, then your application will be connecting to your slave, or it gets promoted to master, and this becomes the master. In the time it goes down and comes back up again. So this becomes your master. And here again, you need not do anything changes in your application. So your database, instance is accessible to you through a DNS instance. So you have a URL through which you will be able to access, or your connection string that is given to you for your RDS, which you're going to access master. And when your master is down, internally that particular DNS is going to route you to the specific slave, or your like updated master, rather than any application level changes that is required. So high availability is a multi-AZ that you need to enable. Then let's say if you have users that are greater than 10K, then decoupling would be important. So here if you see, the number of instances in your web layer or your application layer are increased now. They have, like, initially they had like one or one cases, but now as the number of requests are increasing, you can easily scale your application layer or web layer. But when it comes to database, we had only master and slave. But how to increase the performance? Let's say the number of reads are way too high that your one database is not able to cater, then that will become a bottleneck. Irrespective of the number of horizontal scaling we do for your web layer or your application layer, your database layer is going to become a bottleneck. And that's where the concept of read replica comes into picture. So when you talk about a read replica, important thing to remember here is that it will be an asynchronous replication. There will be an asynchronous replication between your master and read replica, and then all your instances can start reading. Though your write can only happen on master, your instances can start reading from the read replicas. So the difference here between a multi-AZ feature and a read replica feature is that multi-AZ is mainly to enable the high availability, and read replica is mainly for increasing your performance so that the reads can happen parallelly from here. In multi-AZ feature, the standby is not going to be used until your master is down or there is a failover that is happening to your standby. But in a read replica, the reads can happen while the reads and writes are happening on master also. I see there is a question. Is it a pure 3-tier architecture? Yes, that is correct. This is a pure 3-tier architecture. This is only for failover for application and not used for disaster recovery, right? Yes, this is mainly the failover and not for disaster recovery. Yes, right. So disaster recovery would mean that your entire region is down and you would like to get it up in a specific separate region. And for that, we'll have to think about the automated backups or the snapshots and how to restore those snapshots to get these up and running. You'll have to think about the automation even to get the EC2 instances with the application layer and the web layer come again. So there'll be a lot of backups and automation required based on the RT and RP requirements to meet the disaster recovery. So does this help, this specific in async read and write? So this master to standby is a synchronous application, and read replicas, it is asynchronous applications. Okay, there's another question. In read replica, is there a master and slave? So read replicas are just read replicas. They are replicated from the master. But read replicas can also have a read replica, further read replica if required. But then you have to think about the latency, because master would create a read replica. We can have up to 5 read replicas. For RDS, except Aurora, we can have up to 15 read replicas. But in general, we can have up to 5 read replicas, and each of the read replica can have more read replicas. But then there will be a latency to have a read replica from a replica. And then each of these read replica, if required, can be converted into a master. They can become a master. Also, you can upgrade it to become an independent database. And we can also have a read replica in another region altogether. So even for the disaster recovery purpose, if you think about that, if you have a read replica in a separate region altogether, then it can be used for disaster recovery purpose. But then that read replica will have to be promoted to a master if that is required. It's not going to do a automatic failover. And we will look into these like concepts when we talk about in the database section in more detail. Here I'm trying to explain at a very high level how you can achieve the resiliency and the performance. Now this comes more interesting now. With this, it's a typical 3D architecture, great, but what better can we do? How can we shift load to increase performance and efficiency? How can we do that? So this is where your storage comes into picture. So in your most of your website server, like for example, you have a blogging website or you have a WordPress website. Okay, so few things in a WordPress. Most of the data is reads rather than write. So any one blog that is written, once it is written, there'll be very less edits to it. It'll be more of the reads that will be there. And secondly, the data that is already written, it is static in nature. It's not dynamic. It's not going to change with every read. So this is where you can think about, having your static assets in a storage layer and providing these static assets through a CloudFront distribution to the end users directly without involving any compute resource at all. With that, you will not be need to have any compute resource to fetch the static resource and provide it to your end user. So that's why you can always use S3 to save your static assets, and it comes with, and if you're storing your assets in S3, the storage in itself is highly durable and available object storage, right? We have looked into these, that how resilient S3 storage is. It achieves 11 nines of durability, and it makes by making multiple copies of the data across. So once you have your static data on your S3, it automatically is resilient. And then you can use CloudFront to distribute that data, and we will look into that. So if you see, so if we have S3 here we can have your static data, and you can distribute to end user via a CloudFront. Okay, and then to increase your performance further, even for the dynamic content, we can think about having Amazon Elastic Cache. So all your frequently accessed data is stored in your cache here, so that the data does not, every time you get a query from your database, from your web front for a specific data, if it is not changing, then it need not go to the application layer, create the query and query it from the database. If it is already cached, it is going to serve as it is. For static data, the caching is done here at the CloudFront, and for dynamic data, we can do the caching here in the Elastic Cache. And then how does DynamoDB come into picture? Storing a session state. So let's say if a website is for a specific user, not a blogging website, but let's say for a specific user, that how user is progressing for the session state, then because each of these requests can be going to any specific application web layer instance or application layer instance, it's not that they are always being redirected. Multiple requests for a specific user is not being redirected to a specific EC2 instance. It can be redirected to any instance. Then the user will not be able to have that session state stored unless you store the session state at the client side through the cookies or something like that, which is also a way. So there are server-side session states as well as client-side session states. So there are advantages of using the server-side session state. And because server-side session state is more of a key value thing for this specific user, this is a session state. And we can always use your DynamoDB to store that session state. So now with this 3D architecture, so the previous one was definitely a typical 3D architecture, but this one is a more resilient, more performant, if you see. So what extra that is done is that all the static assets are stored in S3 and they're distributed via CloudFront. And having CloudFront is a CDN, it's content delivery network. So it has it is much more closer to the end user. So if you go to the global infrastructure, right? And if we talk about your, CDN regions AZs, and I'll go to the cloud front. It's not mentioned here in this particular, but it has around uh, two, yeah, 45 countries and territories served. So this is mere exactly, various points of presence. Yeah, these are the, sorry, this is the points of presence. So we have around 216 points of presence. When we say points of presence, they're actually edge locations or the edge caches. This is where your content delivery network is, and this is where exactly your data can be cached. So think about that. If you have a global service and if your data can be cached into these edge locations, then it's very easy for your, or it's very fast for your end user to access that data. So any static data can be accessed via CloudFront through via S3, and any dynamic data to increase the response time. So what we have done is we have introduced elastic caches, we introduced read replicas. For high availability, we have used multiple availability zones and have your EC2 instances scaled across multiple availability zones, and your database availability is achieved by enabling the multi-AZ feature. So there will be a lot of scenarios to test. If you want to have a high availability for your database, will you be using read replica or you'll be using multi-AZ? It will be multi-AZ. Then there'll be question, or like a scenario based on synchronous replication or asynchronous replication. Synchronous replication is multi-AZ master standby. Asynchronous replication is read replica for performance. And that gives you this now provides you a good enough resilient and performant infrastructure for your 3-tier web application. And this would be the summary for the same. Yeah, go through this article in detail later on. I'll be sharing these but now let's talk about more scaling your AWS for greater than 500k users. So let's do that. If anyone is interested, there are case studies on how Netflix works. So Netflix is on AWS. So there are case studies on how Netflix works, and I believe everyone understands, what phenomenal job Netflix is doing in delivering content to millions of users across the world with a very low latency. So go ahead and read that. It'll be really interesting. Now, if you have like more than 100, 500k users, then how are you going to, what changes do you need to do? But before we start that, any questions on the part 2? So part 2, I would say, is one of the most important article. Any questions here? If not, probably we'll move on to part 3. Okay, I got a question. When to opt for a vertical scale up or a horizontal scale out of EC2 instance database? So exactly, when to opt for a vertical scale. In case if you anticipate or you do not anticipate your load to increase beyond a specific level, and you see that that can be handled by your single server, then go ahead and use a vertical scale. But there will be a lot of drawbacks for using that, because if there's a single server and you have used vertical scaling for that server, then you'll not be able to achieve high availability. So in that case, you might want to have a similar scaled up or a vertical scaled instance in another high availability. But in case if you have already having into availability zones, then you would like to load balance it. And if you're load balancing it, then you can you need not use that powerful EC2 instance. Only cases where it is like a non-critical use case and to save cost. So if you have a specific scenario in which the cost is not an important factor, sorry, the cost is a very important factor in which you will not like to have a cost increased. What is not important is the criticality of the application. So in case even if the application is down, the user might retry in some time to get that. In that case, your vertical scaling would work, because then your verticals, you'll be having just one instance and it will be available, and because you're not having multiple instances of the same, then the cost would be less. It will be just one instance. And even if it is down for some time, then you can have a monitoring around it, that whenever it is down, do a restart, or uh, you can just set up auto scaling as one. What happens is, if you set auto scaling as with the maximum as one, is that whenever it sees that there is a zero instance running, it is going to switch. It's going to instantiate one instance. It will make it one. So that's when you will be using vertical scaling. And horizontal scaling, I would say, anytime and every time. Horizontal scale is the way to scale up your applications, mainly for applications which are for enterprises. Uh, Again, for database, the same rule applies. Like for database, if you're going for a vertical scaling, it will hit its own limits. For database, you'll have to be more careful that if there is only a single instance running, then you have to rely on automated backups and the snapshots that you would take to restore the database in case the database servers goes down. If the database server is going down and you have a backup, you will have to restore it, but there might be a significant downtime during the backup getting restored. So your overall application might not be performing during that time. Again, if it is not a non-critical, if it is a non-critical application, we can do that. It's going to definitely save the money, because with database it also comes about with the licensing cost and other maintaining costs. So you're going to save money on that. There is another question: will there be any downtime for vertical scale up on AWS resources like EC2 DB2? Uh, yes, there will be a downtime, and we'll discuss about that when we'll be talking about these. So when we talk about EC2 scaling, there are multiple things when we might to scale. We might need to scale the storage of EC2 instance. We might need to scale the memory part of it or core part of it, right? So we might to change the instance family. So there are ways to do that, and we'll talk about that. And same with database. Okay, so we'll move to part 3 now. So this is where you can, like a way to make your whole infrastructure kind of more efficient, I would say. So it's already resilient, it's already quite performant. Now you can make it more efficient and cost effective. One way is to analyze your pattern of the traffic, and with that pattern traffic, you can uh, create rules for auto scaling and provision capacity, so that your overall uh, performance, as well as it is cost effective performance. One way is to ensure that you have more servers running all the time and your website will always be performant. But if you can analyze the traffic, that there are specific hours during the day in which you have more traffic, then you can have the more servers during that time itself, and for the rest of the time you can always have less servers. Or you can even set up dynamic scaling policies of auto scaling to ensure that you have more servers in a specific time. So all comes down to a specific traffic. For example, let's say you have a website, and then you do a reporting, and that reporting is done at every day, let's say at 2 a.m. Then for your reporting engine, you might want to have instances for 2 hours at a particular day of time, and you might want not to have those servers running. So all those kinds of things can be analyzed, and you can tune your infrastructure accordingly. So this is again this same way. Here we have those caches mainly at. So here they have shown it in a two-tier architecture rather than a three-tier architecture. They have used caches where your first request comes into, and in case if there is the data is not available in cache, it will either go to read replica or the master to get the data. No handling is happening directly with the standby. That's important. Unless there is a failover and uh, standby becomes the master, there'll be no read or write directly happening with the standby. It is purely for failover and not for performance. For performance, it is either the read replica or the cache, and you'll have to understand when to use a read replica versus when to use a cache based on the load, based on uh, uh, the cost that you would like to, because each replica would be another instance, so there will be a cost associated with it. All right, so based on that, you'll have to uh, come up with the exact solution. Now then, there is a way to introduce automation, and this would be important. So all this is great, but let's say this entire thing is down. You'll have to ensure that you need to get everything back again, either for mainly in the disaster recovery region or otherwise. And unless the entire thing is automated, it will be very difficult of to get the exact same application running without losing data or getting into delays or issues. So for that, there are multiple levels that are there. So there are high level services like I said, Elastic Beanstalk and Opswork, which manages on your behalf all the deployments and stuff. And then we have CloudFormation, through which you can actually uh, code your infrastructure. It is infrastructure as a code. So if you want to create a EC2 instance, then instead of going to the console and clicking it through, you have a JSON template or a YAML template through which you can just execute, and the resources will be created. And then we do have EC2, which is like the bare minimum on which everything needs to be done on your own. But you can always use CloudFormation to automate those things on EC2. So read about these automation strategies and how it should be done, and which scenario what should be used. There will be a few questions or like understanding based on when to use Elastic Beanstalk versus when to use Opworks. And yeah, there will be a understanding of CloudFormation will be required anyways when you will start working with AWS. To start, it's always good to go through via console and work with these services for hands-on. But otherwise, you'll be mainly working with AWS CLI or AWS CloudFormation when you'll be working on actual AWS projects. There'll be you might not be even having access to AWS console in your production environments, or in your company's organization, based on the policies at your organization. Then, as I said, we do have code deploy. We have we call it code star. It's a full CI/CD pipeline suite through which you can uh, use code commit as your source repository, and it is based on the Git. And use code deploy for deploying your application. We do have code build to build your code, and then all of these can be hooked up together to make a code pipeline. So these are more important concepts for developer associate, your CloudFormation, your code deploy, code pipeline. But for solution architect also, these would be a good to know, and there would be a few scenarios based on which you'll have to understand the differences between these. And then you have this automated, you have a great website that is running, and it is able to serve your customers in a performant way, with the most sophisticated manner. But it's always good to keep monitoring those to understand and preempt any failures that might happen. So we can use metrics and monitoring tools, and this is where your CloudWatch, CloudTrail will come into a picture to understand how, like the host level metrics that you can see that a specific EC2 instance, what's the CPU utilization rate, whether it is going high, low, at what time you should think about adding another server, or what time you should be thinking about removing a server. How is your storage IOPS working? So like IOPS is input output, like the performance. So how is that working? Do you need to have more storage so that your website becomes more performant, or is it like at a stage where uh, it might break? So all those understanding you'll be able to get through your metrics. So you can create a dashboard out of these metrics and just keep monitoring those dashboards to understand what's the next step that you should be doing, or analyzing the patterns. Then there's aggregate level metrics, which is mainly at the ELB level, at how much traffic is coming in, how is it getting distributed, understanding that. And then the log analysis, you would like to put a way to automatically analyze a log and flag any discrepancies that you might want to know in advance, before it gets too late. And the CloudTrail is a good way to do that. You can track the API level activities that is happening, and even for the security, it is good to understand. And then there are ways to irrespective of what is going on within the AWS, you might want to take a step back, think about the whole infrastructure as a black box, and just think about the external site performance. You can use like third-party tools to see how this site is performing, and if case you want to do anything to make it more performant. That's at a high level. uh, and then we'll go on to the last part, which is scaling on AWS for greater than 1 million users or 10 million users. We will talk about that. But before that, any questions? And now we'll talk about this scaling on AWS part 4, 1 million users. And this is where if like in the previous section, we saw that we already created a very resilient architecture and a performant architecture. But if that starts cracking, that means that your website has become hugely popular, and you might want to think about re-architecting uh, and see what better you can do, because you already have a very good architecture in place. And this is where it starts coming with service oriented architecture. And that's where your microservices architecture would come into picture, that you would like to have even your application layer. You want to have your application layer into multiple microservices, so that each of the microservices does not become a single point of failures. And how these microservices talk to each other in between. Like you can use REST APIs to talk to each other, or you can use decoupling mechanisms like SQS in between, that one microservices writes to SQS, and then other microservice reads from there. Or you can want to have each of these microservices their own databases, so that the database does not become a bottleneck. But then there will be a trade-off between how would you aggregate the results from each of these databases. There's a lot of design level considerations that you have to think about when your website becomes hugely popular. But yeah, so the foundational concepts perspective, let's go through the foundational concepts. Decoupling application tiers into prepare for horizontal scaling. So this is like each application separate tier. But we are talking about even having application into multiple service oriented architecture. If you want to go more granular, then come up with your microservice architecture for each application level tier. Choosing among the database options available for AWS platform, yes, that's there. You can go for SQL, RDS, NoSQL, DynamoDB. And for RDS, how would like to increase performance by replicas, or have availability by multi-AZ. Then shifting component workloads using for the performance that we discussed about, using auto scaling to scale to a specific correct EC2 instances, and then automating your software development lifecycle with AWS services. But going forward, it's like service node architecture. And then this is the part that I like the most. Don't reinvent the wheel. This means that there's a lot of managed services already available, which can be used to quickly develop your services. For example, your queuing, I would say, or SNS for notification services. You can all use SNS or SQS already, so you do not have to create your own queues for that, or manage those queues. They're already managed by AWS. They're already highly available. They're already resilient. So any data that is put in a queue, it's already highly available and resilient. Then we do have, this is where you can think about, let's say in your application, if something goes down and you want to take a specific action onto that, then you can always have a SES, which is more of a simple email service. You can have a email that goes out to a specific user, and then that person can look into what needs to be done. to automate that, you have AWS Lambda for a specific things. Instead of having manual tasks, you can automate them using AWS Lambda. And when you do it through a Lambda, then it is going to get executed only when there is a specific action that is required. That means that you're not uh, uh, paying for a service that is just created only for the like a specific scenarios. Whenever that specific scenario is going to happen, the trigger is going to be set and this particular Lambda function is going to hit. That's when you're going to uh, get billed for, or the pricing would be happening. So all of these, lot of there are managed services that are already present, which can help facilitating you to understand which part of your application needs a refactoring and how that can be refactored very, very quickly. And these are just sample services. One of them, what you will see, is SWF, a simple workflow service, which is there, but we have a newer version of it, which is step functions. And that's really a very good service when it comes to orchestrating multiple tasks. So let's say if you have an application which needs a lot of orchestration, then you have step functions which can be very useful in implementing state functions. So let's say if a particular application goes from state 1 to state 2 to state 3 to state 4, and each of the states has a specific steps to perform, then step functions is a way which is going to give you that functionality, a lot of functionality out of the box. You just need to configure it in a way that is needed for your specific use case. So yeah, so here it is. So they have kind of showed how your multiple applications, if you have multiple worker instances, microservices, they need to talk to each other. They can always use SQS as a placeholder for the data. Your one microservice does some processing, puts into a queue. Other microservices takes it from the queue, does processing, puts it another back into the queue, and that's how you can implement a pub sub architecture. As I said, you can use your Lambda for any specific activity that you would like to do. So use these peripheral managed services to scale your application. Let's say your user increases more, 5 to 10 million users, then it will start uh, again showing cracks, and not probably from an application perspective, because now you have scaled it to using all the managed services, and you have made the components that are serverless, required to be serverless, made serverless. But still you have a database that has a kind of a limitation, even with all those read replicas, elastic caches. And it's more for SQL database. And if there are any database administrators here, they will be able to appreciate the concepts like database federation or sharding. So like in database federation, you would be having databases for your specific use cases that you might, let's say if you have an e-commerce website, then you might want to have a separate database for products, separate database for orders. So you would like to store a different kind of data in different types of uh, different databases, and that is called database federation. And then it is sharding, and sharding is more of a kind of a horizontal scaling of database, I would say. Not horizontal, I would say it's kind of a way in which you might want to have data split, that half of the data, or a chunk of a data is stored in one database, and if any particular query is there, then we need to go to that particular database to run there. As they've given an example here, yeah, if you have a users, then last names from A to M will be ranging in one database and rest in another database. So any data coming for a specific user with a name A is need to find that particular shard and go there. That's another way to do it. Again, in this kind of database tuning, there are drawbacks. Like if you want to do aggregate level metrics, then becomes very difficult to do. And that's when you feel that the SQL is no longer working, or there are parts of data which is better to be put into NoSQL. Like for transactions, you might still want to have SQL, but for all other kind of data, you want to go to NoSQL data. And that's pretty much that I had to share. So I'll be sharing this article series with you, or you can just simply search for scaling on AWS part 1, and you will be able to find that here. So, and this should help you at least in getting started in understanding the concepts of resiliency and performance. I don't think we have discussed much on secure applications, or for that matter, cost optimization. Yeah, cost optimization we did discuss when we talked about storage solutions, that instead of distributing your static assets through EC2, it's always better to do it via S3 and cloud front. It's much more cost effective and resilient. Any questions? And I see we are about time already. So yeah, any questions? If not, then okay, there is a question. Yes, Prasad, can you share the Excel spreadsheet you showed in the beginning? So I'll be sharing all the details. I'll put it on our WhatsApp group. Yes, I'll be sharing the recording. I'll be uploading it onto the YouTube, hopefully by today end of day or maximum by tomorrow. Yeah, any more questions? Yeah, feel free to ask. Schema conversation tool. Yes, schema conversation tool is would be part of associate exam. I'm not exactly sure whether there will be a specific question on that or not, but it is a concept that we should be understanding along with the DMS. So when we discussed about DMS, I think I should be adding SCT to the Excel also. Let me do that right away so that I don't forget it. So let me bring the Excel up. So SCT is a schema conversion tool, and DMS. Where did I mention the DMS here, right? So along with DMS, I would be including SCT. So when you are migrating data from one data source database to target database, and these databases might be different. That, for example, you are migrating your data from SQL Server to MySQL, then there are few schema level changes that is there, and SCT is going to help you in that schema level changes, and it even goes one step ahead in giving you suggestions for store procedures and tables and views and stuff. So once you match the schema between your source and target database, then you can use DMS to transfer the actual data. Okay, then there is another question. How is professional essay different from associate essay from difficulty level perspective? If you ask me, professional essay is way to another level. It's really, really difficult. You need to have a deep understanding of each services. Associate level essay, I would say, from difficult perspective, I would say give it a medium, and professional is going to be difficult. I struggled with professional in terms of even the time management. The scenarios is every question in professional essay is going to be a scenario based, and you will be having four options. Even those are scenarios, and it all depends upon kind of the understanding and interpretation for you. It's very time consuming in terms of each question would be kind of a paragraph that you'll have to read, understand what exact scenario it is, and then go through each of the answers, which again would be not less than a para. So it's kind of reading one page for every question. And so for professional, I would say that a lot of more preparation is required than associate. You'll still be able to, like with 4 to 6 weeks of study and hands-on, it will be easy. But for professional, a lot of previous experience also helps, and a lot of hands-on helps. Okay, next question is essay, will there be a CLI command questions? This again, it's very difficult to answer a very specific question like this, whether there will be a question on this or not. There are random questions, but as a topic, CLI is important, and it's good to have a hands-on practice on CLI. As I said, for example, using CLIs to replicate your S3 data from one region to other. What command will be used? Or something like that. It will be useful to understand these CLI commands, not in great depth. From developer associate, it will be required to be known in a great depth, but CLIs and APIs would be important for SA associate also. So seems there are no more questions. So thank you everyone for your time today. I hope this session was useful to everyone, and it will help you guys to get started on AWS. I'll be sharing this Excel sheet in which we have listed the topics which will help you in a solution architect exam. Great. With that, I'll call the session to an end. Thank you all again. Bye bye.